Hello, welcome to Basic 2 Tech for students, teachers, and math education. Today's video, we shall be looking at Introduction to Trigonometry Functions. Trigonometry functions are called circular functions, and also it shows the relationship between the angles and sides of a given triangle. We have three basic trig functions. They are sine, cosine, and tangent. We also have other trig functions, which include cotangent, secant, and cosecant. All these can be derived from the basic trig functions, which are sine, cosine, and tangent. Now, let's look at the types of trig functions. What you see on your screen are different positions of the triangle. The side opposite the angle is called the opposite, as you can see right here. The sides opposite the angle is called the opposite, while the side opposite the right angle triangle is called the hypotenuse. The side opposite the right angled triangle is called the hypotenuse, and it is also the longest side for a right angled triangle. Now, the side that is carrying both angles is called the adjacent. Now, from this triangle, we can show the different trig functions. The trig functions are applicable to right angled triangle. Now, let's start with the sine function. The sine function. Sine function is written as sin, the angle, that is a sine function. Now the sine function is the ratio of the opposite to the hypotenuse. So sine function, which is sine theta, is equal to the ratio of the opposites. So it's the opposite over the hypotenuse. So we use HYP for hypotenuse and OPP for the opposites. So this is the trig function for sine. So sine theta is equal to opposite over hypotenuse. The next function is the cosine function. The cosine function is written as cos then angle. The cosine function or cos theta is the ratio of the adjacent to the hypotenuse. So it is written as adjacent over the hypotenuse. So this is the trig function for the cosine. The next basic function that we have is the tangent function. The tangent function. It is written in short form as tan, then the angle. The tangent function is the ratio of the opposite to the adjacent. So it is opposite over adjacent. And this is the trig function for tangent, opposite over adjacent. Now, we can remember these basic or primary trig functions by using a mnemonic, which is called so, car, toi. This is a mnemonic through which we can remember these basic trig functions. Now the S is for sine, The the S is for sine theta, the C is cos theta, and the T is tan theta. So sine theta is sine theta, the O represents opposite, the H represents hypotenuse. The C is cos theta, the A is adjacent, over the H is hypotenuse. The next one is T is tan, the tan theta, equal to the O is for opposites, over the A is for adjacent. So with these mnemonic, we can easily remember these basic trig functions. Let's look at the other trig functions like the cosecant. We have the cosecant. We have the secant. And we have the cotangent. We can derive these trig functions using the basic function. Now, cosecant is written as CSC. Cosecant is the reciprocal of sine. So, cosecant is equal to 1 over sine theta. It is the reciprocal of sine. And what is sine? Our sine is opposite over hypotenuse. So we have 1 over opposite over hypotenuse. So when we do the math here, our cosecant becomes hypotenuse over opposite. So this is the ratio for cosecant. Our next is secant. Secant is the reciprocal of cos theta. That is, we have 1, our cos is adjacent over hypotenuse. So that means that our secant is hypotenuse over adjacent. This is the trig ratio for secant. The last but not the least is the cotangent, which is cot or cotangent. It is the reciprocal of tan, 1 over tan theta. That means that we have 1 over tan theta is opposite over adjacent. So therefore, our cot or cotangent is adjacent over opposite. So these are the other trig functions that we have, and these are all used when we are talking about trig functions. Now let's look at how we can use these trig functions to solve problem. If we are given the length of one side of a triangle and the value of one angle, we can set up equations using trig functions to help us find the length of the other side. The steps are: number 1, you must know the given side and the unknown side. I repeat, you know the given side and the unknown side. Number 2, you set up an equation involving either sine, cos, or tan, depending on the sides or angles that you are given. And step 3, you rearrange to make the value you are trying to find the subject of formula. I repeat, number 3, you rearrange the equation to make the value you are trying to find the subject of formula. Now, let's look at some questions. Here's our first question. It says find the length labeled x in the triangle below. Now, this is a right angle triangle, as you can see right here. It's a right angle triangle. So this side where the two angles lie is the adjacent. So my adjacent is my unknown, is x. This side, or which is the perpendicular side opposite the angle, is called the opposite. So my opposite is given to me as 5 meters. So what next? The angle, our angle is given to us as 45 degrees. So now I'm giving adjacent and opposites. So if you look at our SOHCAHTOA, where you have your opposites and your adjacent, that should be your tan. So we use our tan theta equal to opposites over adjacent. So now we log in the values. Our angle is, we have tan 45 equal to, our opposite is 5. Our adjacent is unknown, which is x. So what we'll do next is to transpose. So we have x tan 45 equal to 5. So to find x, we divide both sides by tan 45 over tan 45. This cancel this. So we're left with x equal to 5 over tan 45. What is tan 45? Use your calculator. Tan 45 will give us 1. So therefore our x, or our unknown side, is 5 over 1 gives us 5. So that's 5 meters. So the unknown side is 5 meters. Now let's look at our next question. Here we're asked to find the side labeled x. Again, this is a right angle triangle, as you can see right here. This side opposite the angle is the opposite, so our unknown is opposite, is x. The side facing the opposite is the hypotenuse, so my hypotenuse is giving us 10 meters, and my angle is giving us 30 degrees. So again, which of the trig ratio do we use? So we have to set up the equation. Again, we can use our SOHCAHTOA. Now we are given opposite and hypotenuse. That goes for the sine. So we use sine ratio. So we have sine theta equal to opposite over hypotenuse. Next, we log in the values. So we have sine 30 equal to opposite is unknown, is x, over our hypotenuse is 10. Next, we transpose. So we have x equal to 10 times sine 30, or 10 sine 30. So therefore our x, which is our opposite, is equal to 10 times sine 30. Again, use your calculator. Sine 30 will give us 0.5 is 0.5. So therefore our opposite is 10 times 0.5. That gives us 5 meters. 5 meters. So our unknown side right here is 5 meters. Let's look at our next example. Here we are given, again, it is a right angle triangle, as you can see right here. So the side that is carrying the right angle triangle and the angle right here is adjacent. So our adjacent is 6 meters. The side facing the opposites, or the longest side, is our hypotenuse. So our hypotenuse is given to us as x. Our angle is 30 degrees. Again, we can set up the equation using our mnemonic, which is SOHCAHTOA. SOHCAHTOA. Here we are given adjacent and hypotenuse. That goes for cos. So what we use in this case is the cos ratio, which is cos theta equal to adjacent over hypotenuse. So we have cos, our angle is 30, equal to adjacent is 6, over our hypotenuse is unknown, is x. What next is that we cross multiply. So we have x times cos 30. So we have x times cos 30 equal to 6. Next, to get my x, I will divide both sides by cos 30. So I will divide 6 by cos 30. And I will divide my left hand side by cos 30. So cos 30 cancel cos 30. So we have x equal to 6 over cos 30. What is cos 30? Put that in your calculator. Cos 30 will give us 0.8660. So therefore, when we divide that, what do we get? So 6 divided by 0.8660, that gives us 6.9. So we have 6.9 meters. So that is how we apply trig ratios to solve triangles or right angled triangle. What about if we're asked to find the angles? If you recall, our examples were all finding the sides. To find the angle or to find the missing angle in a right angle triangle, we have to use the inverse. We use the inverse trig function. We use the inverse trig function to find the angle. That means that we convert our sine theta becomes sine inverse of theta, becomes sine inverse, becomes sine that means that our sine theta becomes sine inverse, our cos theta becomes cos inverse, then our tan theta becomes tan inverse. This means that, for example, if I have a question, let's say I have sine theta equal to, for example, 30 on my right hand side, and I have to find the angle. So what this means is that theta becomes equal to, the sine becomes an inverse of whatever is on the right hand side. It means that the angle becomes the inverse of whatever is on the right hand side. So if this was cos, it becomes cos inverse right there. If this was tan, it becomes tan inverse. So the angle becomes the inverse of whatever is on the right hand side. With that, we can solve for angles in a right angle triangle. So let's look at an example of calculating the unknown angle in the figure below. Here we're asked to calculate the unknown angle in the figure below. As you can see right here, our angle theta is unknown, is y. This is a right angle triangle. The side carrying the right angle triangle and the angle is our adjacent. So our adjacent is 14.2 centimeters. And the opposite, which is facing the angle, is 8 centimeters. So again, we have adjacent, we have opposites. So what we use here is the tan. So we use our tan theta equal to opposite over adjacent. Now we log in the values. So we have tan y equal to opposite is 8, adjacent is 14.2. So we have tan y equal to 8 divided by 18 by 14.2 is 0.5634. You can double check that. 8 divided by 14.2, 0.5634. So therefore, to get my angle now, I have to make my right hand side tan inverse. So we now have y equal to the tan inverse of 0.5634. So therefore my y is equal to use that in your calculator, press your press your shift, then press your tan, then type in 0.5634, and that should give us 29.4. So approximately 29.4 degree. So that is the unknown angle for this right angle triangle. One more question is this. Again, our angle is unknown. The side facing the angle is our opposite. So my opposite is given to me as 10.39 meters. The longest side is the hypotenuse. So my hypotenuse is given to me as 12 meters. Again, look at this. We have opposite, we have hypotenuse. That should be the sine ratio. So therefore, we use the sine theta equal to opposite over hypotenuse. The more you master the different ratios, you should be able to easily set up the equations without even using the mnemonic SOHCAHTOA. So what we'll do now is to log in the values. So we have sine y equal to opposite is 10.39 over hypotenuse is 12. So therefore we have sine y equal to 10.39 divided by 12 gives us 0.8658. So again, to find the angle, it means that we have to find the sine inverse of the right hand side. So therefore we have y equal to the sine inverse of 0.8658. Again, press your second function, press your sine, and type in the value. That should give us 60 or approximately 60 degrees. So that is our final answer. So this is how we solve questions involving trig functions. So thanks for watching, and I will see you in the next video.